So now we want to talk about how do I name an oxyacid. So remember, an oxyacid is going to have H plus as the cation, and it's going to have a polyatomic anion. So how I'm going to name this, the oxyacid, depends on what this polyatomic ion is. So if you remember, polyatomic ions have two endings. They can end in ate or they can end in ite. Ates and ites. So carbonate, carbonite. Okay? So based on what the polyatomic name ends in is going to help me determine how to name my oxyacid. So if my polyatomic anion name ends in ate, then the acid name ends in ic. Okay, so that's my first rule. If my polyatomic anion name ends in ite, I-T-E, like nitrite, then the acid name ends in OUS. So it's going to be the base name of my polyatomic ion, so whatever the polyatomic ion is, base name with ic, or the polyatomic base name with us, and then the word acid. So that's one word, and this is another word. All right, so let's do some practice. So this says for us to name H2SO4. So pretend like I don't know this is an oxyacid. I just say name this. First thing you should see is the AQ, which means I know this is an acid. So when you see AQ, you're like, ooh, it's an acid. Then you look and you say, I've got 1, 2, 3 elements. So it means it's not binary, it has to be an oxyacid, because binary only has 2 elements. So now I know it's an oxyacid. So now I have to figure out, well, what is the anion? Because I know it's always H plus the anion. So it's always H plus the anion. So my anion has to be SO4. Since there's a 2 here, you could cross up to get the -2. So now I know what the formula is for the anion. But I need to know, well, what's the name of that guy? So SO4 2- is sulfate. So now that I know that he's in 8, now I go here and I follow these rules. 8s are going to become ites, where ites becomes us's. So since it has the 8 suffix, I'm going to change it to ic. So it's going to be sulfuric. Now you might say, well, why isn't it not sulfic? Okay, so they kind of go back and extend the sulfur part of the name a little bit more instead of sulfic. I can understand why you would think it's sulfic. This is partially where you just get practice with the different acid names to help you know that it's going to be sulfuric acid and not sulfic. And then we have the name acid. So sulfuric acid. Okay, so sulfuric acid. All right, let's do another one. So I want to name this. So the first thing I notice is the AQ. So the AQ tells me this is an acid. Now I notice that there's 1, 2, 3 elements. So since there's 3 elements, now I know it's an oxyacid. I know there's always H, so now I got to figure out who's the other guy. So the other guy is my SO3. He has a -2 charge. So now that I know what the formula of the anion is, now I have to figure out his name. So you can go to your polyatomic ion chart if you don't have it memorized and see that SO3 2- is sulfite, I-T-E-E. So if it's I-T-E, then the acid is going to end in OUS. So this is yet again, it's not sulfus, it's sulfurous. So So another thing just to get practice with, and then we add the name acid. All right, let's do some practice. Do some more practice. And I forgot to go back and add AQs to all this, so just go ahead and write that in. So I say name the following. So you don't know what these are, you just know it says name. So the first thing you see is these AQs. So you know, oh, acid, this guy is an acid. So then you say, okay, well what kind? Is it binary or oxy? So you look to see that there's only 2 elements. So 2 elements means he's a binary. So I know it's H plus this non-metal. So binary, the first thing you would write is that prefix, hydro. So you write the prefix for hydro, and then you have to figure out what is this. What is the non-metal? So the non-metal is sulfur, and then you add the ending ic. So hydro, and then sulfur, and then ic. So hydrosulfuric, and then the word acid. All right, let's do the next one. I see the AQ, so I know it's an acid. I notice there's 1, 2, 3 elements. So if there's 3 elements, I know this is going to be an oxyacid. I know it's always H plus the anion. So then I know that the anion has to be the ClO3. So I need to find the ClO3 in my chart. He actually has a -1 charge. And I discovered that that is chlor-8. Once I know that he's chlor-8, I know that if the polyatomic ion ends in 8, I'm going to switch that to ic. So I do chlor-ic, and then the word acid. Don't do hydro. Hydro is only if it's binary. If it's oxyacids, they don't get the hydro. Just the name of the polyatomic with the proper ending and the word acid. All right, next one, AQ, so that means he's an acid. I see 1, 2, 3 elements. So that means he's an oxyacid. I know it's always H plus the anion, so the anion has to be NO2, which has a -1 charge. I go to my polyatomic chart, I find NO2. NO2 is nitrite, it's ITE. So if it's ITE, the acid name is going to end in OUS. So no hydro, because it's not binary. I just write nitrous, whoops. Nitrous, because I dropped the ITE. Okay, nitrous acid. So nitrous acid. So we have to figure out that it's an acid. So all of my acids have to have acid in the name. Binaries have the hydro, oxys do not. Then it's the name of the nonmetal with ic if it's binary. If it's a polyatomic anion, then it's the name of the polyatomic ion with 8s becoming ics and ites becoming us's. All right, so now we can go from the formula to the name. So now we want to practice, how do I go the other direction? If I have the name, how do I go to the formula? And so that's what we're going to talk about in our next lecture, is going the other way around.